Do you know, the largest hailstone ever officially recorded measured 8 inches in diameter? It fell near Vivian, South Dakota in 2010, weighing almost 1 kilogram. And that's not even the heaviest. The heaviest hailstone ever recorded weighed more than 1 kilogram, falling in Bangladesh during a deadly storm that killed 92 people. Just imagine that for a moment. Ice falling from the sky, as heavy as a brick. So, how do pieces of ice in the sky grow this big? Why don't they melt before reaching the ground? And what exactly is happening inside a thunderstorm to create these frozen giants? Let's break it down on our channel, Earth Diary. So, what is hail really? Hail is not just frozen rain. It's solid ice balls, sometimes smooth, sometimes jagged, that form inside powerful cumulonimbus clouds, the same clouds that produce thunderstorms. Most hailstones are small, pea-sized or golf ball-sized. But under the right conditions, they can grow as large as an orange, or even bigger. Inside a thunderstorm, air doesn't just move, it races upward. These upward winds, called updrafts, can reach speeds of 100 to 160 kilometers per hour. That's strong enough to lift raindrops high into freezing upper parts of the cloud. And it also keeps heavy ice particles suspended in the air. Without these updrafts, hail simply wouldn't exist. Every hailstone starts small. It begins as a raindrop, or a tiny ice particle called droplet. This tiny particle is carried upward into very cold regions of the cloud, where temperatures are below freezing. There it freezes, becoming the hailstone embryo. Now comes the real magic. The growing hailstone doesn't just fall straight down. It goes on a looping journey inside the storm. Here's what happens. It falls downward, collecting supercooled water droplets. Then a strong updraft pushes it back up again. This cycle repeats multiple times. And each trip adds a new layer of ice. Think of it like an onion, layer after layer, building up over time. If you cut open a hailstone, you'll see alternating layers of milky white ice and clear ice. Each tells a story about where the hailstone has been. White, opaque layers form when droplets freeze instantly, trapping air bubbles, whereas clear layers form when water spreads over the surface and freezes slowly. This happens because the hailstone moves through different parts of the cloud. Regions with low water content cause instant freezing, but with high water content causes slow freezing. That's how those beautiful concentric rings form. Enjoying the video so far? Make sure to watch till the end to discover how hailstones grow this massive. And don't forget to like, share, and subscribe for more. In powerful storms, especially supercells, something even more dramatic happens. The hailstone can be carried sideways. It travels long distances inside the cloud and stays suspended for 5 to 10 minutes or more. This gives it enough time to grow massive. Eventually, one of two things happens. It becomes too heavy for the updraft, or it gets pushed into a downdraft. And then, the hailstone begins its final descent, and it falls fast. Large hailstones can hit the ground at speeds exceeding 160 kilometers per hour. Because they fall so quickly, they don't have much time to melt, even when passing through warmer air. That's why giant hailstones can reach the ground almost intact. Hailstorms may last only minutes, but the damage can be devastating. They can destroy crops in minutes. Farmers call it the white plague. It can break windows, dent cars, and damage roofs. In extreme cases, they can even be deadly. For centuries, people tried unusual methods to stop hailstorms. In parts of Europe, people believed that ringing church bells, firing cannons, and creating loud noises could disrupt hail formation. It sounds strange, and it doesn't work. Modern attempts like cloud seeding are still being studied, but results remain inconclusive. Hailstorms are just one part of a much larger system, thunderstorms. They are powered by rising warm, moist air, the release of latent heat, and powerful updrafts and downdrafts. They grow, mature, and collapse, all within a few hours. And during their peak, they become nature's most powerful ice factories. So, the next time you hear hail hitting your roof, remember, each tiny ice ball may have traveled kilometers inside a storm, survived powerful updrafts, and built itself layer by layer before finally falling to Earth. So, if you found this fascinating, don't forget to like, subscribe, and join Earth Diary for more incredible science stories from our planet.